this session, we will see the Hive components which all are available with Hive tool and which is related to Hive and what is the purpose of that component. So as per the diagram, you can verify that there are few components like driver, metastore, MapReduce, HDFS. So these are the main components of Hive. So let's see these components in detail one by one. The first one is the metastore. This is the component that stores the system catalog and metadata about tables, columns, partition like MySQL stores. So first one is the metastore, the first one. You can see in the blue color that it stores the schema of a table like table customer, like customer ID is big int and gender is string. So this is the schema or table. So metastore is the component which stores the schema of the table. The second one is driver. The driver is like it manages the life cycle of Hive query language statement as moves through Hive. It is also maintained a session and execution. So basically you can say driver is the main component which manages the life cycle of Hive QL statement. In between the red one you can see the metastore and between the query there is a driver which executes every time. So this is the component which launch the application. When you query a particular table like select star from customer where gender is male, then it goes to the driver. Then driver launches and verify the metastore and gives you the result. So driver manages the life cycle of Hive query language statement. Third one is MapReduce. A job basically submitted to perform both map and reduce tasks. So you can see like once the driver is launched the application, then it goes to MapReduce. So MapReduce is the cycle, a component which executes to give you the result. So when a job is submitted, when a query is performed, then it performs on both mapper and reducer tasks and gives you the result. Then the fourth one is HDFS, that is Hadoop Distributed File System. It is a storage and maintain the source of data and the database file system. So in the HDFS, basically it stores the actual data, the raw data you can say. So from there you insert that data in your Hive table and then query. So the HDFS is basically used to store and maintain the data. Then the last one is query. The query is the main component of Hive because if you are running any query like select star from table name, then this statement is to execute the script written using Hive syntax. So this is the main component which executes your query like select star from customers where gender is a male. So this is the component, like this is the query component of Hive which executes the actual data, which executes the actual query and gives you the results. So these five are the main components of Hive. Cover the Hive comparison with traditional RDBMS, that is Relational Database Management System. So in this we will see how it is distinguished between the Hive and SQL or any other traditional databases. So let's start with first difference. Hive supports the traditional database by supporting SQL-like interface, but it is not full database. Hive can better be called as a data warehouse instead of database. We can say Hive is basically a data warehouse where you can store your data in the HDFS cluster, or from there we can grab our data in the Hive tables and then we can query our tables to get the records on a terminal. So Hive is not a database, but it is as a data warehouse technique. One of the major difference you can say Hive is Hive enforces the schema on read times, where RDBMS stores the schema on the write times. So you can say Hive only displays at read only mode. You can say where you can only read the data from the tables. Also in RDBMS, record level updates like insert, delete are possible. In our traditional databases, we can say we have update, insert, delete, whatever we want to do with our table records, we can do with our traditional databases like SQL. Wherever these are not allowed in Hive because Hive was built to operate over HDFS data using map review, where full table scans are the norms and table updates is achieved by transferring the data into new table. It means in the earlier version of Hive, there was no update or delete command which we can execute. But in the current version of Hive, we can say Hive supports the data updation commands like update, delete, insert. All the commands are quite possible in the latest version of Hive. It was not available in the earlier versions of Hive. Also, you can say Hadoop is a batch oriented system. Hive doesn't support OLTP, that is online transaction processing, but it is closer to online analytical processing, but not ideal since there is a significant latency between using query and receiving the reply. So that's why we say that it is an analytical processing tool where you can analyze your data because your data is on the HDFS and you can insert that into your table to analyze that, like how that data is and how you can insert that data in your table to verify the records of one query. Also, RDBMS is best suited for dynamic data analysis where fast response are expected, but in Hive it is suited for data warehouse. So it is basically a fast technique. Relatively a static data analysis, fast response are not required when data is not changing rapidly. You can say like in Hive, as it is a data warehouse technique, there is no update in the data very frequently. So you can query your data and analyze the result in fast way. Hive is a very easy scalable at low cost, but RDBMS is not that much scalable. That too is very costly to scale. It means as Hive is an open source tool that is provided by Apache and it is an open source tool there, so there is no license fee required for Hive, but for the RDBMS it was a costly because there was a license for SQL, Oracle or any other databases. But as Hive is a free and open source tool, so there is no license fee. So these are the main differences for Hive and our traditional RDBMS. In this session, we are going to see how we can download Hive tool on Ubuntu terminal and which all files are necessary to update for Hive installation. So these are the steps how a user can install the Hive. First, you need to download the Hive tar file. You can say it is a zip file. Then once it is downloaded, in the download folder, you can extract using tar xzf, then the zip file name. After that, you create a folder as a Hive name once you extracted the tar file, then you need to create a folder for your Hive installation. You can create a folder using the sudo mkdir in the appropriate folder where you want to install your Hive. I have created in user local Hive. Then using the move command, you can move your unzip file to that folder. And once that folder is moved, then you can update your bash rc file for your Hive installation. So these are the paths you need to set. First you need to set the Hive home path, that is the directory path where you have put your extracted Hive file. Then you need to set the class path. So once these done, then you can start your Hive. Once this is done, you need to move to the bin folder to your installed directory and just need to execute /hive or only Hive, and then you can see that your file is installed. You can say your Hive is installed successfully and your Hive is open in the terminal. But first, make sure your Hadoop is running properly on your terminal. You can verify that using JPS. If Hadoop daemons are not displaying, then you can start your Hadoop using start-all.sh command. This is how you can install your Hive. So let's see it on terminal. This is my Ubuntu terminal. On this, let's first see if my Hadoop is running or not using the JPS command. I have pressed JPS and enter. You can see that my all daemons are running perfectly. Then first let me show you where I have downloaded the directory. I have downloaded in the downloads folder and unzip that and move that file to my user local Hive. So this is my Hive installed directory. Once this is done, first thing you need to do, you need to update the file, the bash rc file with your Hive installed directory. Let me open the bash rc file. You can use the vim /bash rc. So now you can see my bash rc file is open. I'm going down so that I can show you the Hive installed path. So you can see from the Hive section, this is my Hive path which is set over here. Once this path is set, then you can start your Hive. So this is done properly. Let me come out from this directory using $Q explanation sign and press enter. I came out from the Hadoop, and then you need to start the Hive. To start the Hive, you need to type Hive from your terminal. Once your Hadoop is running, I have pressed enter. It will take around 30 to 60 seconds to open your Hive terminal. Once Hive is displaying in terminal, then you can see that Hive is installed successfully. Else it will give you any exception. So now you can see my Hive is came in the terminal. It means my Hive is installed successfully and now it is running fine. So in this video, I have shown to you how you can install the Hive and how you can start your Hive from the terminal. We are going to cover Hive characteristics and Hive features. So let's start with Hive characteristics. As you can see, Hive is a system for managing and querying unstructured data into structured format. It means whenever you are having your data in unstructured format, it could be Excel, text file, CSV format, any unstructured data, it could be audio, video, that can be formatted into structured format and then you can load that data in your Hive table. After that, you can query your table as per your need to identify, to pick any record from the table. It basically uses the concept of map reduce for execution in the background. It means whenever you are executing your Hive query in the background, it is executing the map reduce job. It displayed how many mappers and reducers are running to execute this query. And also the main second characteristic is it also uses the HDFS for storage and retrieval of your data. It means you can store your data on your HDFS cluster and from there you can access and retrieve your data into your table and then you can query your table to get the record as per your need. So these are the two main characteristics of Hive. So let's start with Hive features. Basically, the first feature is Hive internally executes map reduce and translate Hive query language statement into set of map reduce job and execute it on a Hadoop cluster. It means, as we have discussed earlier, it is using the map reduce execution job in the background, and on the terminal when you are executing your query in Hive, you can see that it is displaying the mapper and reducer records. It display process wise and in the percentage how much percentage mappers are completed and then how much percentage the reducers are completed. So it display all the features of map reduce and the status of map reduce on the terminal. It is also using the batch processing over large amount or large set of data. So you can execute your query in batches. It means if you execute your query in one go, you can create a particular shell script file and inside that you can execute your multiple queries. So that's why it is a batch processing. So you can execute multiple commands, multiple queries from one file. And it is also very easy to use SQL like language, as we are testers and we are aware of SQL. So it is very easy to understand how it approaches. It is as simple as the SQL language. So all the concept which is available in SQL, you can implement those things here in Hive also. You can create the tables in the same way, you can query the tables in the same way. It is also have the high scalability and low latency response. So you can get your response time in very less amount of time because it executes on a multiple cluster. So whenever your complex queries are executing, then it revert the result in a quick time. Hive is also, you can say, mostly suited for data warehouse application. So you can store your data into HDFS, and from there you can execute your queries. You can insert the data in your table as per your need. So basically it is a data warehouse technique to store your data on a HDFS cluster. It is also, you can say, table stored in a subdirectories of warehouse. So you can see that it is also using the partition bucketing from the subdirectories. The partitioning and bucketing we will cover in our upcoming sessions. Basically, as of now, we can say like partitioning is a feature where you can say partition is a feature where you can split your data as per your need. Like you have a country data, then you can divide that data as per the city, as per the state. So this comes under partitioning. We will see in our upcoming sessions how partitioning and bucketing we can implement. And also the actual data stored in flat files. So simply the data is stored in your flat files only. So these are the main features which is available for Hive.